Hi everyone, today we're going to be presenting a webinar on APIs and parallel processing. So just for a quick agenda, we're first going to go through some introductions, both to Thorogood, myself, and Lauren, who will be presenting today. And then we'll do some setting the scenes, talk about the methods of parallelization, and then just wrap up the webinar in general. So first, my name is Melissa Horan, and I'm a data and analytics consultant here at Thorogood. I am joined today by my colleague, Lauren Potechin, who also works as a data and analytics consultant at the firm. Just a quick overview of who Thorogood is. We are an independent consulting firm that works within the juncture of analytics, technology, and business. We operate globally out of offices in London, Boston, Philadelphia, Singapore, Sao Paulo, and Bangalore. We create data-driven business solutions through our use of multi-skilled consultants within the areas of data engineering, data science, and data visualization. Within our customers, we tend to work within three verticals, those being consumer goods, pharma and healthcare, and then financial services and insurance. Our customers are mainly made up of Fortune 500 companies or blue chip organizations. At Thorogood, we practice a technology agnostic approach, meaning that we work with a multitude of different technologies. Here on the screen, you can see different companies that we partner with or different technologies that we partner with, some of which including AWS, Microsoft, Databricks, and GCP. At Thorogood, we do tend to kind of work with different technologies to best serve our customers. So now that you've learned a little bit about me and Lauren and Thorogood, let's kind of get into API parallelization and talk a bit about what an API is. So first, we're just going to introduce the use cases here at hand. So let's start off with some examples of how you might use an API. So the first use case is surrounding product information. Say you're trying to collect information about all of the products on a retailer's website, and there's an API that has that information. However, this API is not compatible with batch calls, which we'll get into a little bit later on. So you could manually call this API through a single API for each product that you're interested in. But that's a quite large investment of time and effort. So what do? You'll want to automate your API calls and ideally parallelize them. But how do you do that? So later in this webinar, we're going to go into that a little bit more in depth in different methods that you could take. A second use case that we're going to be exploring today is where you might see an API with geocoding. Maybe you're a retailer looking to calculate the distance from each individual customer in your data set to the nearest store. You can use Google Maps API to get this information. But once again, you'll be manually calling the API for each single instance of your customers, which will take a really long time. So again, what do you want to do? So let's first understand what an API is. An API stands for Application Programming Interface, which effectively means just the communication between two pieces of software or applications. So let's set the scene of where you might see an API within your everyday life. Suppose you're searching for a hotel room or a car rental or airline tickets on a website such as Kayak or Expedia. You're going to have different filters where you can specify your preferences, including something like location or price or accommodation, and so many other factors. In order to book the room or the airline or the car rental, the website will need to interact with the hotel's booking website, which in further will let you know if a room is available or if a car is available within the parameters that you gave. In this example, an API works to connect the Expedia website to the particular website that you are asking information regarding the filters that you provided. The hotel's website or the car rental's website will send this information back to Expedia through the API so that you as a user can understand what's available to you through the Expedia website within the parameters that you established. So in terms of where we might see an API being used, again, APIs allow for two applications to communicate with one another through the sending and receiving of requests. There are a few different examples where we might run into APIs. First, we have API connections to databases. So when we query a database, we're sending a request in an accepted language, and the API is understanding of that. And then the it'll return the result in the form of a tabular output or an operation. We can also see APIs being used in DevOps practices, such as CI/CD practices, which are interacting with the cloud, APIs to manage infrastructure and to do operations such as delete, create, and modify. The final place we might see APIs being used is with connecting to both internal and external data sources. So in the previous example I gave with Expedia, the website, is using an API to connect to an external data source, such as a hotel website or an airline website. So we can provide information on external data providers. So first, we're going to go through a REST API. So there are multiple different types of APIs that can be used. But in this presentation, we're going to stick to talking more about what a REST API is. A REST API stands for the Representational State Transfer. It makes use of HTTP methods to get, post, put, or delete data. So its basics functionality is to take advantage of existing data. So an API is a collection of communication protocols and subroutines used by various programs to communicate between them. So we can use this REST API as a way to send a request. This request will then be used within the API to determine what response the server needs to give. And then finally, the client will get the requested information. So the next kind of thing to cover is single API versus batch API calls. If you remember in our use case with the products, we said that there were no batch API calls available. So let's get into a little bit of what a single API call is and how we could use single versus batch API calls. When deciding to use a single versus a batch API call, the first thing to do is to check the documentation to determine whether a batch API call is available. As stated before, there are some times where only single API calls are available. So on the left-hand side here, we have a graphic displaying what a single API call looks like. So in its basic functionality, within a single API call, we request for each individual single product if we're using our product use case. And in turn, the API will return requested information separately. Whereas with a batch API call, we could request multiple product information at one time, and then we would receive all that product information at the same time when the request is finalized. In general, single API calls normally work better when there's a little bit less traffic on the site and are better in terms of reporting partial failures, which makes sense with batch API calls. You might not receive this partial failure until the end of all of requests being put through. However, batch API calls are better in terms of network latency and efficiency. So when looking at ways to kind of optimize our API calls, checking if the API allows batch calls may be the first step in our journey to optimize our solution and also kind of work towards that parallelization of API calls. So why do we care about APIs? Why do we care about parallelization? So the first thing is APIs are giving us a means to internal and external data sources, which means that we can access publicly available data sources as well as get access to data from other vendors. Secondly, it can be done programmatically, which means that we have standardized protocols such as REST APIs or other API protocols such as SOAPs. And also it can be integrated quite easily into common programming languages and frameworks. And then the third reason that APIs are really important is that there's a lot of flexibility to get what we want. So we can have parameters specifying which products that we want. We can have parameters specifying whether or not we want a certain vendor. And also we can have synchronous and asynchronous pulls of the information. So just some challenges that come up with APIs. The first being time. So obviously we've talked about the single versus batch API calls. Within that, there are time considerations. If you have a million products that you want to get information on through an API, doing a million single API calls is going to be quite costly in terms of time and efficiency. Secondly, there's call limits. So APIs will have a certain call limit stated within their documentation. In our product use case, where we want to make a million calls with single API calls, a call limit may cause some issues. So it's really always important to check the documentation to see the limit and work around that limit as you're developing methods to get the information as well as to parallelize your API. And then the final consideration is structure. So the structure of an API means like the structure of which the API returns the information, which may also pose a challenge when using an API to receive that information. The schema in which the information is returned may make it difficult to parse out the necessary product information, or the necessary information may not be easily compatible. So within our next few slides, we're going to be talking about some methods of parallelization. So what are we trying to do when we say parallelize APIs? In general, we're trying to minimize time and effort and also automate and scale. So we want to build solutions that allow us to optimize our time and optimize our effort, while also building solutions that are easily scalable and automated, so they're not just manual processes. So next, we'll go into the methods of parallelization. The first method of automating your API calls is to use for loops. So first and foremost, you'll need to write a script to call the API. This can be done in your language of choice, some popular options being Bash, Shell, and Python. The example here on the screen is written in Bash. It uses curl, which is a library and command line tool for transferring data over different network protocols. The script uses the get command to retrieve the data from the specified URL. Additionally, the API in this example requires two headers, which we call. Next, we will need to collect a list of the IDs to call the API for. For example, if you're looking for information about products on a retailer's website, you'll need a list of the product IDs you're interested in. Then you will write a loop around your script so that you can call the API for each ID. In our example, the script is calling the API for each item ID in the list we generated, and that item ID is being used in the URL. Lastly, you'll need to write code to combine the results between each iteration of the for loop, so that because each iteration of the for loop will return a separate result. The exact logic isn't shown in this example, but you can either combine your results within your for loop or save each iteration within the for loop and then combine the results afterward. So let's go over some benefits and using a for loop for parallelization. The main benefit of using a for loop for API calls is the automation it provides. With a for loop, you can just feed it a list of IDs and let it run and then come back to a combined result. This certainly takes less time than manually calling a single API call by yourself. Another benefit to for loops is that they are a pretty common feature of most coding languages, so it's likely that the language you're most comfortable working in can be used as long as it has the proper packages or libraries to call the API. And one last benefit is that when using a for loop in a script to call the API, the entire process can happen in one tool and even in one notebook. So all you need is the coding interface, and for loops are a simple and efficient way of automating API calls. Now for some limitations. So on the other hand, the for loops also have some challenges and limitations. The first one may be that the language you typically work in doesn't have the packages or libraries to be able to call an API, so that you have to use one that you're not used to working in. Or maybe your language of choice can call APIs, but it's using a library that you're not familiar with. So just the fact that you might have to use unfamiliar languages or libraries, and there could also be a learning curve attached to the exact languages or functions that might be required to call your API. The second limitation is that we have this combination logic that needs to occur because the for loop returns a separate result for each iteration, and therefore there's some extra code and logic required to combine those results. This is effectively more effort and also likely more computing power and runtime. And lastly, Depending on the coding interface that you use, the for loop may not be executing in parallel. For example, Databricks Python for loops only run on one driver node and therefore is executing each iteration in series. While there are a few possible limitations for loops, they are a great first step in automating API calls and also possibly parallelizing them. So now I'm going to hand it off to my colleague Lauren to get into a bit more methods of parallelization.
So the next method that we'll talk about that you can use to call APIs in parallel is to multi-thread. So this method starts very similarly to using a for loop with a script that calls the API and a list of the IDs to use. So the last step is to use the thread pool package. The thread pool package allows you to submit tasks and run them in parallel, where each task runs on a different thread. There are at least two ways you can use the thread pool to parallelize API calls. You could have a notebook with the call script and then a second notebook that uses thread pool. For this option, the task that you're submitting would be the notebook run. Alternatively, you could submit the script directly as the task, and this would put all of the code into a single notebook. The example that will be on the screen here uses the first option. First, we will import the thread pool package. Then you will define the parameters to give the dbutils.notebook.run function. In this case, we need the name of the notebook that we're going to run and then the keyword arguments or kwargs that the notebook takes as inputs. The notebook in this example will run the API call script for a given item ID, so we want to feed each item ID in our list as a keyword argument. Then we open the thread pool and tell it how many threads we want. In this example, we want there to be one thread for each item in our list. Then we submit the task to the thread pool, which in this example is the notebook run. And then finally, we will close the pool. So multi-threading shares some of its benefits with for loops. The script itself can be written in your choice of coding language. However, to use the thread pool package specifically, the wrapper notebook will have to be written in Python, as it is a Python-specific library. However, there may be some equivalents in other languages that serve the same purpose. And just like for loops, the multi-threading method happens in one tool, maybe in one notebook or maybe in multiple, but all you need is a coding interface such as Databricks. And lastly, an advantage of the thread pool package is that you can configure the number of threads that run, as we saw in the example on the previous slide, and that helps optimize the efficiency of the process. And so just as multi-threading shares benefits with for loops, it also shares some limitations. The result is returned separately for each run of the notebook, so this method does require extra code to combine all of the results. Additionally, there is an absolute limit to the number of threads that can exist, so multi-threading may not work on its own if you want to call an API, say, 1,000,000 times. The next method is to use a for each with a pipeline orchestrator. Like the other methods, it starts by writing a script to call the API and generating a list of IDs to call for. Then the last step is to create a pipeline to run the script for each ID. The example on the screen shows a pipeline in Azure Data Factory, or ADF, which is Microsoft's pipeline orchestrator. Notebook 1 would be a notebook that creates the list of IDs and writes them out to a file. Then the lookup activity will read in that list file and feed it as an input to the for each activity, which will run the script notebook. This is an ADF example, but other technology providers have similar pipeline orchestrators that can do this as well. Another interesting thing about using a for each activity to run Databricks notebooks specifically is that you can use it in conjunction with job clusters. So a job cluster essentially means that you're creating a new computing instance for each iteration of the for each. Since it creates many small computing instances, this saves you from worrying about overloading one medium-sized or large computing instance. One of the benefits of this method is, once again, that you have your choice of coding language for the script. And if you're using a tool like Databricks, you can even code in multiple languages within one notebook. And then the for each activity of the pipeline orchestrator will often let you configure how many iterations to run at once. For the ADF example, the parameter is called batch size, and that determines how many activities will run in parallel at a time. So if you have 200 items in your list and configure batch size to be 40, then you'll have 40 notebook runs happening at once, and the whole process will take about 5 times the length of a single notebook run. And so, like the other methods, the for each activity still writes out each iteration's result separately, so it still requires code, maybe in an additional notebook at the end of the process, to combine the results together. Additionally, the for each activities do have a limit on the total number of iterations. For ADF, the total limit is 5,000, which means this method may also not work best for calling an API 1 million times. You can, however, get around this limit by nesting your for eaches. If you put a for each inside of another for each, then you can get 5,000 squared, or 25 million iterations. And we'll talk about this a little bit later when we get into partitions. The next method to call APIs in parallel is the UDF, or user-defined function. A user-defined function is what it sounds like, a custom function written by the user. The example on the right will show what a UDF can look like for calling an API. To start, we define the name of our function, which is execute API, and then also the inputs required for the function. In this example, we want to intake the variables verb, URL, and headers. Then we will code the logic for our function. Here, we're looking at the verb variable, and if that value is get, then we're using the Python requests library to get information from the API at the given URL with the specified headers. If the verb is not get, then we will instead post information to the API at the URL with the specified headers. So to use a UDF to call an API, you'll need 2 steps. The first is to create your input to the function. In this example, you'll want to start with a data frame or table with at least 3 columns, verb, URL, and headers. And then you'll want to write some code to use the UDF to call the API for each row in your input table, and then save the result as a new column in your table. And so the big benefit of using a UDF as compared to some of the other methods we've talked about is that it will return just one result in the form of an extra column in your table. So no combination logic is needed. Additionally, the entire process will happen in one tool, which is your coding interface. And lastly, the UDF provides you with a lot more flexibility. Depending on how you define your function, you could retrieve information from the API for one ID and update the information in the API for another. While a UDF does allow for more flexibility, the flip side to that is that it is more complex to develop than some of the other methods. Additionally, depending on the engine that's executing your code, it may not parallelize the computing like you want it to. Be sure to read up on how the engine you use, like Apache Spark, parallelizes your code so that you can make the computing as efficient as possible while developing. The last topic I'll cover isn't really a method in itself, but can be used in conjunction with the methods we've already talked about. When we discussed limitations of some of these methods, we've mentioned that some of them have limits as to how many iterations can run at a time or in total. Partitions are a good way around that. Basically, once you have your list of IDs to call the API, you'll split it into several pieces called partitions. Then you can combine the techniques we've already discussed and apply that method to each partition. For example, say you want to make 1 million API calls. First, you might split your list into maybe 5,000 lists of 2,000 IDs. Then maybe you'll use a pipeline with a for each activity, and for each of those 5,000 lists, you run a notebook that calls the API using a UDF. So now you have an extra layer of parallelization that will decrease the time the whole process takes to run. The last step with partitions would be to experiment with the number of partitions you use. There isn't just one correct number. The optimal partition number will depend on the tooling and the methods that you're using. So today we've talked about several methods that you can use to parallelize your API calls. The biggest takeaway is that it is unlikely a single method will be perfect for your use case. It's often the mixing and matching of methods that will provide the most efficient way. This way, you can get around the limitations of some methods and capitalize on the benefits of others. Some combination of one or more of these methods will give you a more efficient way of calling APIs so that you don't have to spend as much time or effort to retrieve the data you need. And that is all we have for today. Thank you all for tuning in. If you could take a moment to share feedback by scanning the QR code shown here, it would be greatly appreciated. The survey will also give you an opportunity to share some information about topics you're interested in, and if you'd like to set up a time to chat with Thorogood about initiatives that you're working on. Feel free to reach out to us with any questions. Thank you, and have a great day.